All right, so now that it's 11, I think we can go ahead and get our workshop started today. So welcome everyone to the second workshop in our Research Tools Workshop series. And so the purpose of these workshops is to introduce tools and to introduce the tools that are available through the NHERI SimCenter and also DesignSafe, just so that graduate students are aware of the tools available to them, and also as a way to learn how to use these tools. And so through this, students also have the opportunity to learn from and ask questions from someone who is an expert and more familiar with these tools. So this workshop series has been organized by multiple wonderful students within the NHERI Graduate Student Council. And so to quickly introduce the NHERI Graduate Student Council, this is an organization that was established a little over a year ago now, and our purpose is to build a diverse graduate community for natural hazard researchers, to connect with diverse mentors in the natural hazards community, to attend natural hazards research and career workshops, to encourage diversity, equity, and inclusion conversations, and to learn about the impact of research on natural hazards practice, and to gain leadership, service, and funding opportunities. And this has been a wonderful experience for myself and many others who've joined the organization and leadership positions within the organization. And so if there are graduate students or researchers here that are not currently members of the NHERI Graduate Student Council who are interested, you can scan this QR code here on this slide to learn more about our organization and to get involved. And so I would like to now introduce our speaker and presenter for today, Dr. Weynang Zhang. Dr. Zhang is a research associate within the High Performance Computing Group at the Texas Advanced Computing Center at the University of Texas, Austin. He received his PhD in civil engineering at the University of California, Los Angeles, and his work focuses on developing computational and physical modeling and data analytics methodologies in design and performance assessment of life pipelines and infrastructure systems to further enhance their resilience and sustainability. And so today he's going to introduce the machine learning and AI resources that are available to students on DesignSafe. And so thank you so much for joining us today, Dr. Zhang. I'll now turn things over to you. And if people in the audience have questions, please hold them until the end. And so then we'll have time at the end of the presentation to address any of those questions that you have.
Good morning, everyone. And thank you, Jasmine, for a great introduction. So again, my name is Weynang Zhang. I'm a research associate at the Texas Advanced Computing Center at UT Austin. So today I'm gonna go over the research tools that DesignSafe provided for the machine learning and artificial intelligence applications. I will try to go over the steps so you can say how you can start from opening Chrome and log into DesignSafe web portal, and then upload your data, upload your Jupyter notebook, run Jupyter notebook through the DesignSafe web portal, and then do your machine learning or artificial intelligence analysis remotely, meaning from the DesignSafe web portal. So let me share my screen. Thank you. So this is the DesignSafe website. And I think we recommend people to use either Chrome or Firefox to launch the DesignSafe website. So I guess most of you have a DesignSafe account. And if you have your account, then you just log in, enter your username and password. Yeah, this is how it looks like. And then the first thing I want to talk about is the use cases we have prepared. So if you click workspace and the use cases, you will see all different kind of use cases products we have prepared for different research fields. For example, we have the machine learning and AI resources, which is what I'm going to talk about today. We also have the geohazard use cases, and hurricane and windstorm and seismic. So by clicking all these different links, you will know more about these use cases. So today, I will talk about the machine learning and AI resources. So in this use case product, we prepared 4 different examples using different machine learning algorithms from simple to complicated. For example, we have the linear regression. Secondly, we have the random forest, and then we go with neural networks, and eventually we try the convolutional neural network to classify some images. And for every single example, we have the Jupyter notebook. You can, and also the corresponding data, so you can click the link, and then you see the code and the actual data. So then let me go back to the DesignSafe web page. The second thing I want to talk about is the DataDepot, because as we know, for machine learning and AI studies, the data is pretty important. And here, before you run anything on DesignSafe, of course, you have to upload your data to this DesignSafe DataDepot, or you can transfer the data from the community data or the published ones to your own DataDepot account, so that you can use that data and then do your own things. And here, the example-based introduction to machine learning, this folder is transferred from the community data. So if you click the community data and you scroll down, at the very end, you see this use case product, which corresponds to the use case products on this website. So if we click this use case product, you will see we have different subjects. Some are more physics-based, like OpenSys, OpenFOAM, or uncertainty quantification. We have QualFAM, and also some fictable experimental data. And today, what I will introduce and talk about is this one, an example-based introduction to machine learning. So if you want to transfer any of this data to your own account, you just select that one, and then you click this button, copy. So, and you select where you want to transfer this data to. So here I just transfer it to my data. And you click copy here, then it will go to your own account. I have already copied this data and paste to my own account, my data. So here it is under my data, and then an example-based introduction to machine learning. So if you simply click this link, you will see the 4 examples, from linear regression to random forest to artificial neural networks, and eventually convolutional neural network. Let's just quickly click the first one, the linear regression. Okay, so here you see, here we have 3 Jupyter notebooks, and we have the data. And the last one is the requirements, meaning what the required Python packages you need to install. For example, for this specific case, we have to install NumPy, Pandas, Matplotlib, and the sklearn. And this is, so if you only want to say view these Jupyter notebooks. You can just click those Jupyter notebooks. Come on. Yeah, here you are. So you can just view all the entire Jupyter notebook, and you can also download and modify based on your own purposes. That's it. And then I want to talk about how to run Jupyter Notebook on DesignSafe. So here, to do so, you click Workspace and then Tools and Applications. And we have multiple tools and applications. We have simulation that has lots of different research tools. I think we have both the commercial ones and the open source ones, like ANSYS is the commercial F1 element code and LSINA. But we also have OpenSys SDK for the structure analysis tools. And also we have SimCenter tools and visualization and analysis. So here, to run the Jupyter Notebook on DesignSafe, you click Analysis and then Jupyter. And then you click Launch. Okay, here you are. So if I go back to my data, that is all the folders under my data. So as I mentioned, I already copied this folder, the machine learning AI one, to my data. So if you click my data and this folder, and we start from the linear regression. So if we look at the first Jupyter Notebook, okay, so this example was prepared by my former colleague, Joe Van Tassel. He's now an assistant professor at Virginia Tech. And this example is for the prediction of the housing price based on the transaction date, house age, distance to nearest MRT station, and number of convenience stores, and some other features using the linear regression method. And the first, I think this is just a normal Jupyter Notebook. If you have run anything on Jupyter Notebook, you know how it works, right? You just click the run button here to run each cell, or you can click this stop button to interrupt the kernel. You can also restart the kernel, clear all outputs, so on and so forth. This is nothing different compared to the regular Jupyter Notebook you use on your own personal laptop. But the first thing I want to talk about here might be different than what you did on your own personal computer, is that the installation of the required Python libraries. So here we recommend people to use the command pip. So pip install anything you want. So here I want to install all the libraries that are listed in this file, requirements.txt, which I just showed to you has, I think it has 4 libraries or packages: the NumPy, Pandas, Matplotlib, and the sklearn. Okay, so let me just run it. If you click this one, the run button, yeah, because I already installed, so it shows the requirement already satisfied, so it has been installed. And then you just here click kernel and restart kernel, so that the system know that, okay, you already installed the the packages, and then you can start from there. And next time when you open this Jupyter Notebook, you don't need to install it anymore. It's already under your account, so you just comment it. Yeah, the rest is basically the same as what you did for your Jupyter Notebook. You first import all the required Python packages you need, and secondly, you load the data you need for the following machine learning or AI analysis. And as I mentioned, this example is using linear regression method to predict the housing price of the unit area. So, and here we have, let's see, 1, 2, 3, 4, 5, 6. Okay, so we have 6 features to predict a single value, which is the house price of unit area. We have also prepared the detailed comments for this Jupyter Notebook. So here are 4 features we use and 1 value we need to predict. Okay, yeah, there are just some sanity check. We print some values to say whether those data are loaded correctly. It is. And then it's just some basic things for the machine learning. You have to shuffle the data and then split the entire database into 3 data sets, right? The training, validation, and test. And we first look at the training set by comparing the Y value, which is the housing price, versus every single feature. So we have 6 features. Here are the 6 subplots. And also, if you are familiar with the linear regression or other machine learning methods, typically we need to normalize the data set so that we want the mean value of the training data set to be 0, while the standard deviation to be 1. So there are many different ways to normalize the data. So here we just manually do it. We compute the mean, and then we compute the standard deviation, and then we subtract the mean. We subtract the training data by the mean, and then divide it by the standard deviation to have a 0 mean and unit standard deviation. Okay, and the next step is to create the machine learning model you need. So here we created the linear regression model. If you are familiar with Python, it's just a 1 single line to do that, because we already loaded some packages or functions from the sklearn. So here you just need to use that linear regression function to create this linear regression model. And here's the result. So the true housing price versus the predicted ones. And of course, this line is the perfect line. If all your predicted results are on this line, that means your prediction is 100% accuracy. And here we show the predictions, and we also show the RMSE, which is the rooted mean square error, which is one of the commonly used errors for quantify the accuracy of your regression analysis. And once we train the data, normally in machine learning study, we predict the validation set and then the test set. So here's the validation set, and we got the RMSE equal to 9.4 compared to 7.75 for the training set, a little bit higher, which is normal. And then we just do some error analysis to say which feature caused the errors, or which feature is the most responsible one for the errors. And then we did something interesting because we realized that maybe by using the linear regression model, or in other words, well, yeah, as you know, the linear regression is like y equals to a1 times x1 plus a2 times x2 plus a3 times x3 plus an times an and plus a0, which is a constant or the intercept. And we realized that maybe we can add more features to decrease the error. And the way, or the normal way people do it, is to add the quadratic terms, meaning that we have x1 square or x2 square, and we append these quadratic terms to the normal linear term. So previously, for example, if we have 6 features, and right now we have 27, so we add 21 more features to the original data set, which comes from x1 square, x2 square, x3, x4, x5, x6 square. So there are 6 terms. And we also have x1 times x2, x1 times x3, x1 times x4, so on and so forth. So total is 6 plus 5 plus 4 plus 3 plus 2 plus 1, which is 21. Then the original 6 features, so total is 6 plus 21, which is 27. And again, we need to normalize the data, and we do it again, the create and train, and also test on validation. So here, if you look at the RMSE for the training set, which has been decreased from 9 point something to 6.0, has been significantly reduced. So it shows that the newly added quadratic terms work. Yeah, and also we try to add, we try to repeat the training, but with the reciprocal terms, meaning that 1 over x1, 1 over x2. And we got the RMSE to be 6.9, which is a little bit higher than the error from the quadratic terms, but still lower than the original data set. And that is what we did for the linear regression example. And we also have 2 other Jupyter notebooks, which shows the learning curves as well as the regularization case. So you can look at the Jupyter notebook and run it on your own personal laptop, or either download and run it on your own personal laptop, or just run it through the DesignSafe web portal. And this is the first example, the linear regression. Maybe a little bit far from our research field because it is for real estate. And the second example I want to show is for a real geotechnical engineering application. So the second example is the random forest one. You just click this Jupyter notebook, and similarly, and the first step is to install the packages. So here, I didn't prepare a a requirement.txt file. Instead, I specifically ask the system to install this package, the sklearn. Actually, I already installed, so here you don't need to install it again after you install one. And the rest is the same as the linear regression example. Basically, you just need to you just need to import all the packages and functions you need for this Jupyter notebook. And here we load this data set, as you can see. So we have the data set, and here we only have 4 features and 1 value that we need to predict, which is the landslide displacement. So this example I can quickly show you. So I can show you, if you go to the workspace and DataDepot, I think it is from Ellen Rothschild, and you can search her name. No, not this one. So maybe published. Yeah, this one. So you can view more details about this example. So if you go to the use cases, and you will find that I have that link for you. So the second example that I use random forest to predict the lateral spreading displacement comes from this community data. So you can view more details of this project and also the published papers by clicking the published button, and then find this project, if you remember this project number. And yeah, this is the data where it comes from. So if we go back here, we have this data set copied from the published data set on DesignSafe DataDepot. And we first load the data, and we process the data by first taking the absolute displacement. Basically, you just add a absolute function to the y value, which is the displacement of the lateral spreading. And then we also classified or grouped the data set into 3 classes, which is the small displacement one, meaning the displacement from 0.3 to 0.5 meter, and the medium and large displacement. So this means that we convert the problem from a regression analysis to a classification problem. So here, basically, we have 3 different classes, meaning the small, medium, and large displacement. And then similarly, we shuffle and split the data set. So now we have the cleaning and test the data set. And here is the confusion matrix function we just copied from elsewhere. We don't need to write it by ourselves. And this cell tells you how to build a random forest model, which is also very simple if we have imported that package sklearn. So here you just need to use this random forest classifier for the classification problem. And if you are familiar with random forest, you know that if you are doing a regression problem, then the function you need to use is so-called random forest regressive. And here we just did a grid search, meaning we tried to find the optimal combination of the hyperparameters for random forest algorithm. For example, the maximum depth of the P and also the number of estimators, the maximum features, and the criteria. And we also did the k-fold cross-validation to make sure that it doesn't have the overfitting. So that is the random forest model we built. And then we just train this model, and then we show the scores or the accuracy, in other words, and we got an accuracy of overall score 0.78, and then we just do some predictions for the test set, and then we use the confusion matrix to verify our predictions. As you know, the diagonal terms, meaning the correct predictions for different classes. So the darker the diagonal terms you have, meaning the higher accuracy you have. So these are the confusion matrices. And we also extract the feature importances, which is a great function of the random forest algorithm. So by plotting this feature importance, we will know that which feature, for example, the distance or ground to water level or the slope, is the most important feature for this prediction. So if you say the distance is the most important one, okay, then you may try to refine this data and to get higher accuracy. And also we print the accuracy score and some other things which is very basic for machine learning is the ROC curve. So ROC curve means the true positive rate versus the false positive rate, and the perfect line is the horizontal line from 1.0 to 1.0. And based on this ROC curve, you will get the AUC area. And if the AUC area is equal to 1, that means you get perfect accuracy. If you get 0, then means you didn't get any correct predictions. So this is the second example. And let me continue to the third example, which is the artificial neural network. So this example, I use the same database as what we used for the random forest, which is the prediction of the letter spreading displacement. And the only difference is that I didn't use the random forest. Instead, I used the artificial neural network. And similarly, the first step is to install all the required packages. So here, besides the sklearn, I installed the most important one, which is the TensorFlow. And of course, you can use the PyTorch to do this artificial neural network case. And again, you need to import the libraries after you install those packages. And these are just repeating the steps that we had for the second example, the random forest one. You load the data, you process the data, you remove some points that you don't need, and then change the data. This is for the confusion matrix, and then this is the how I create the artificial neural network. So as you can see here, I have totally 5 layers. Besides the input and output layers, I have 3 hidden layers with 100, 200, and 400 neurons. Of course, it can be adjusted, and you also need to do grid search to find the optimal parameters. And here, and also I added an early stop signal here. So if your accuracy does not increase, still not increasing after 100 epochs, then it will stop. So here is how it works. It just changes, and you can see the accuracy is going down gradually. Sorry, the accuracy is increasing while the loss is decreasing gradually. Of course, after several steps, it just starts fluctuating, not significantly increasing anymore. That means, yeah, it's already good, and we don't need to do the iterations anymore. So here is the accuracy of this artificial neural network. And if we go back to the random first one, so here we get the 0.786. And if we go back to the random first one, let's just compare what we get. So very similar, and we get the 0.71 for the random first case, while 7.69 for the neural network case. Yeah, this is normal because many researchers have done a great number of studies showing that such, I would say, simple example, actually random forest can make great predictions, and we don't need to use neural network for such a simple example, because neural network may take much more time compared to the random forest, because it needs so many iterations to get converged to such a low loss and high accuracy. And similarly, we just made predictions by using the trained neural network, and we plot the confusion matrix again, same as what we did for the random forest. Well, I think I wanna mention something. Oh yeah, here, and we also save the predicted result to CSV. So you can simply download the CSV, and then later when you write your own script to do this analysis, you can compare with our result to see whether you get a better accuracy or not. Okay, and the very end, the convolutional neural network, CNN. And similarly, the first step is to install the required packages. So let me open here. So basically the same. For this example, we just need to use 3 packages, the NumPy, Matplotlib, and the TensorFlow. And again, you can use PyTorch to do the same thing. It just depends on which one you are more familiar and you like. And we load those required Python packages, basically the TensorFlow. And then in this example, which is a very simple example, is to ask the machine to predict the number given an image. So we didn't create those data. We just download the data from the TensorFlow Keras database. So you just need to load the data from this Keras function, and you get those images. And here is the shape of the data. And as you know, for the images, for every single image, you will have three-dimensional data because it has the RGB data, which indicates the color of every single pixel. So here is just to show the first three images we get from the TensorFlow Keras database, which is 504. People can tell that. And then you need to prepare the image and also the output. We use the one-hot encoding. So then we just did a sanity check. So for example, for this image, well, we can tell the number is 5, and then we print out the Y value after the one-hot encoding, which is correct. So it is here 5. And then the next step is to develop the convolutional neural networks, the CNN. You just need to use this convol 2D for this example because it's a 2D image. And then to define the loss function. And here is the screenshot or summary of the convolutional neural network. As you can see, we have one input layer and then four convolutional layers, and then a pooling layer, and finally a flattened layer. So similar to the artificial neural network case, here are the iterations. Here we only did 10 iterations because first, we already got good accuracy after 10 iterations. Secondly, it takes some time to train these 6,000 images. And as you can see, here's the learning curve. So after 10 epochs, the accuracy has been significantly increased while the loss has been dramatically reduced. And it's almost flat, so we think, okay, 10 epochs are enough for this study. And then we just plot the predicted results. So this, of course, the left column shows the real image we are predicting. And the second column shows the green diamond is the exact value or true value, while this blue bar is the probability from our trained convolutional neural network. And for this one, it's perfect. So our trained convolutional neural network thinks, okay, we have 100%, we are 100% sure that it's 7, and the exact value is also 7, so it's correct. And so for the other 4 cases, and we also print out the prediction accuracy, which is 99%, which is pretty good. And at the end, we also show some field predictions. For example, for this image, well, even human beings have difficulties reading this number, which is 4, and the true value is 4. But here, if we look at our predictions, I think the highest probability coming from the trained neural network is 6, so which is incorrect. And so for these 2 we predicted the 7th for this case, and also this one. So some field predictions, and of course you can pick your database and then make your accuracy even higher. And again, so in this study we have the entire Jupyter notebook you can download and play with, or you can easily transfer all this, for example, the Jupyter notebook to your own DesignSafe DataDepot and start playing from there. So that's for the 4 examples. Just give me 1 or 2 minutes. I will just wrap up. At the end, I want to tell you that, as you can see here, you are doing everything through the Jupyter notebook. Well, and the back end of today's Jupyter notebook is a virtual machine, a CPU virtual machine at the here, Texas Advanced Computing Center. I know that some advanced users, you may want to use the GPU to do your machine learning or AI analysis. We also have that resources. So if you know anything about TACC, here we have a supercomputer called Frontera, which is the most powerful supercomputer for academia. And this Frontera has GPU nodes. So here on this website, if you simply search Frontera machine learning, you will find the first item out of the Google search. And then this page tells you how to run the machine learning application on Frontera using GPU nodes, and how to run it through the command line, meaning without opening the real Jupyter notebook. We also have some videos from the YouTube channel of TACC, many other different interesting topics. Here, I just want to point out this one, the machine learning training day, which is much longer than this workshop. So we have a 4 half-day training happened in this past April. So you will find and each video has around 2 hours long, so totally 8 hours, and you can view all these videos to give you more ideas about how to run large-scale machine learning and AI analysis on our supercomputer Frontera using the GPU nodes. And that's it. Thank you for attending this workshop. Please feel free to let me know if you have any questions. Thank you.
Thank you so much for your presentation, Dr. Zhang. That was extremely informative, especially with a lot of things that I need from DesignSafe as far as tools and applications go. And so now if anyone has any questions, now is the time for them. You can go ahead and unmute yourself and ask those questions, or if you want to type it in the chat, you can also do that. I do have one question about Frontera. How can students access Frontera? I mean, are there kind of requirements, or is it like a process to go through?
Yes, so there is a process. So basically, we recommend users to ask their advisors who can be a PI. So basically, people, the PIs have to submit a ticket through the DesignSafe. I can quickly show you. DesignSafe. Yeah, so help, you click help and then you click submit a ticket. I mean, ask your advisor who can be a PI to submit a ticket and telling us that you need to run what you need to run. Just give a brief introduction about your planned future or like planned research on Frontera, and tell us that you need the allocations on Frontera, and then some staff at TACC or DesignSafe will review your ticket and then give you allocations, and then you can just run anything you need from there. Yeah.
Okay, great. Thank you.
No problem.
Hi, I have a quick question about
Hello, I have a question.
Oh, go ahead.
I would like to ask you, show us grid source CV. Grid source CV, I think it is used for k-fold cross-validation. Am I right?
No, not necessarily.
Can I identify the training and test data separately in grid source CV?
Yeah. I mean, let's say, you know how cross-validation works, right? You split your training data set into 5 or 10 subsets, and then you do the iteration. The first iteration, you consider the 1 out of 5 sets as your test set, while the other 4 subsets as your training data sets, and then you iterate 5 times, you get 5 errors, you find the main error, you compute the main error and also the standard deviation to say if you have overfitting issue. That is how cross-validation works and what it means. While the grid search is that you try different combinations of those hyperparameters, and for each combination or realization, you get a loss or accuracy based on that specific set of hyperparameters. And you do hundreds, thousands of times, you find the best group of hyperparameters that gives you the lowest loss or highest accuracy.
Yes, I understand it, but you know, in grid search CV, we define CV inside of the algorithm as a number of folds. And then the problem is, if I need to make oversampling or undersampling, I want to implement it to just my training data. If I first split my data as a train and test, but how can I implement these two separate data within grid search CV as separately train and test? You know, like I have 20% train and 80% train and 20% test. For my 80% training data, I implemented, for example, oversampling, increase my data. And can I use in that condition grid search CV?
I think so. Well, you just need to define what data you want to use for the grid search and the CV. Yeah.
Okay. If no one else have question, I can continue having some more questions.
I think Richard Campos had a question, Narula. Can we get back to you in just a second?
Yes.
Oh, yeah, I just had a quick question on the regression example. Is that was a machine learning example, right?
You mean linear regression?
Yeah, the linear regression, sorry.
Well, yeah. Well, I think some people consider it as a statistical problem, while some people just think it's, well, a machine learning problem, depending on how you think about it.
I see. How would it be a machine learning problem? Like what would define it like that? specifically for that regression problem example.
I didn't get it. So what do you mean by how to identify it as a machine learning problem?
Right. So you said the regression example can be seen as a machine learning problem. Is that right?
Well, technically, yes, but it's not my field. I mean, the machine learning or computer science people and the statistical people, they already have some discussions on that.
Okay, thanks.
And I saw a problem posted on the meeting chat. Yeah, instead of using the library data, maybe import. Yeah, of course. That's a very good question. So if you go to this DataDepot again, so here you can just click add, or you can here, you can also transfer the data from multiple venues, the box, Dropbox, or Google Drive. Yeah, or you can just upload your data from your personal laptop to this DesignSafe DataDepot.
I think we have time for one last quick question that was in the chat earlier, which is, was the coding that you went through to practice, is that available to public users?
Yes, it is. I think so, yeah.
Great, thank you so much. And yes, so where can they find that the examples that you went through?
Okay, so you go to DesignSafe. Here, you click Workspace, you click Use Cases. So this use cases gives you this link, Machine Learning to AI Resources. And of course, if you are interested in any other topics, we also have very good examples. But here, well, what I showed today, you can find here.
Let me see if I can get that link. I'll just drop it in the chat. All right, so I think that about wraps up the time that we had for questions today. Dr. Zhang, if you don't mind, can I share my screen?
Okay, let me stop sharing. Thank you.
Yeah, thank you. Okay, yeah, and once again, thank you all so much for attending this workshop today. And we hope you join us again for our next workshop, which will be on Friday, January 13th, on developing and benchmarking fragility and consequence functions. And that'll be presented by Dr. Adam Jarnazay. But once again, thank you so much to everyone who attended today. And I would like to give a huge thank you to our speaker, Dr. Weynang Zhang. Thank you so much. And thank you to all the co-organizers that have helped put this workshop series together and have got it moving. And once again, here are those QR codes for students and researchers who want to get involved with the NHERI Graduate Student Council, and also with the working groups within the council that help put on events like these. And so thank you again, and we're looking forward to the next workshops in these series.